You have two half cells. So this is one galvanic cell. This whole thing is one galvanic cell, right? One galvanic cell will have two half cells. One is oxidation half cell and the other one is reduction half cell. The oxidation half cell is always having negative electrode and which is called as anode. And the reduction half cell always has positive electrode and that is called as cathode. Okay, anode is negative, cathode is positive in galvanic cells. And this is a voltmeter, or it can be an emitter, or it can be a globe just to see if the electricity is flowing or not, because the purpose of a galvanic cell is to convert this chemical energy in these electrolytes, in these half cells, into electrical energy, which is in the form of flow of electrons. So we all know that, but sometimes they confuse you, and I don't know why someone get confused because of that. You have electrolyte in half cells. The solution in these half cells is called as electrolyte. And then you have electrons. Electrolyte is the fluid, the solution. Let's write the solution, not fluid. Electrolyte is the solution, and electrons are in the external circuit. Electrons are in the external circuit. Electrons never flow in the solution. I have seen this misconception. Electrons never flow in the solutions. Electrons are always in this external circuit. And they always go from anode to cathode, A to C, not C to A. Okay? This electrolyte releases electrons because of chemical reaction. Electrolyte is chemical energy. And electrons are electrical energy. And that's how galvanic cells convert chemical energy into electrical energy. I've seen this one mark question. And the question was how galvanic cells convert chemical energy into electrical energy. It was one mark question. And the answer was, let me first write the question. How galvanic cells convert chemical energy to electrical energy. That was one mark question. And the answer was when electrolytes and electrodes undergo chemical reactions, bracket, reduction and oxidation, or oxidation and reduction, electrons are released at anode and flow towards cathode through the external circuit. That's it. That was the answer. When electrolytes and electrodes undergo chemical reactions, oxidation and reduction, electrons are released at anode and flow towards cathode through the external circuit. There are keywords in this answer. If you don't have all of those keywords, you may not get full marks. And the keywords are: first, oxidation reduction; second, uh, ex- um, electrons are released at anode and flow towards cathode and through the external circuit. If you don't have these keywords, you will not get that. Now, I'm giving you some time to get your head around this question number one, and then we will discuss that. If you look at the first galvanic cell, reduction always happens at the cathode and oxidation always happens at the anode. So it means in the first galvanic cell, X should be higher than Y, right? So electrode potential E10 should be higher than E20, right? In the second galvanic cell, this is positive. Positive means cathode. Cathode means reduction. So Z should be higher than X, and Z is E3. So E3 is higher than E1. And if I combine this, I get E3 higher, then E1, and then E2.